Hey, what's up, chat? Welcome to Unit 8, Day 3. In today's lesson, we are learning to graph linear functions, whether it is given in a table, a real-world situation, or an equation. All right, and so we're going to start by just kind of giving some steps or some guidelines for graphing. Okay, this is namely when you have an equation, but we'll talk about how to do some of the other ones. When you are graphing an equation, I think it's a good place to start with the y-intercept, right? Because you're going to have it in y equals mx plus b. And so the y-intercept is where it is the b, but it is where we know where it crosses the y-axis. And so we know that that's going to be 0 and some number, okay? So whatever b is, we can put b there. That's going to be whatever that number is, that's going to be where it crosses the y-axis, all right? So we can start by graphing that. And then after that, we're going to locate other points by using the slope, right? And we know slope is rise over run, okay? And so based on our slope, we're going to rise, we're going to run. I do want us to make sure that we are understanding that we can use the slope to find points in both directions. So, we're going to do the slope as it is, but then we're also going to do the opposite of the slope to find points in the other direction. And I'll show you that here in just a moment. And then lastly, once we have a couple points on our graph, we are then going to draw a line connecting the points. Also understanding we're going to put arrows at the end, knowing that that line continues, okay? So let's look at the first one, all right? So we're going to graph the linear function y equals negative 2x plus 1, okay? So we're going to start by graphing the y-intercept, okay? So the y-intercept is b, okay? So this is the y-intercept, okay? And so we're going to start by graphing that, okay? So we go to 1, and that is where our dot is going to be at a positive 1, okay? And then from there, right, I know that my slope, so I'm then going to use my slope, which is negative 2, okay? And that is, I'm going to use the slope to find other points. So I'm going to zoom this in just so you can see this a little better, all right? And so I'll go for my dot, and I'm going negative 2. And I need to know that when my slope is negative 2, that really is negative 2 over 1, okay? Because slope is rise over run. Just got to remember that there's an imaginary 1 underneath there. So we're going to go, all right, we're going to go down 2, then we're going to go forward 1, okay? And then there's a dot. Then we're going to go down 2, and then forward 1, down 2, over 1, okay? So, okay, again, and I know my slope is negative, so that's why I'm going in this downward direction, okay? And I need to put some points in the other direction. So when I have a negative, now my negative is gonna kind of go with the denominator. So I'm gonna go, again, do the opposite. I was going down 2 over 1. Now I'm going up 2, back 1. So up 2, back 1. Up 2, back 1. Up 2, back 1, okay? And so I have plenty of points there, but I could continue graphing points if I wanted to, all right? And so I graphed enough points. Now I am just going to make a line that connects each of these points, all right? And that's maybe not the straightest line, but that is it, right? And so that's how we graph a linear function when we are given an equation, okay? And so if you want, you can pause the video. There's another example that you're going to do on your own, okay? So you can pause it, and then you can do this one since I've just done that. Or I'm just going to walk through these first 3 examples and then let you do the last 3 on your own. So however you want to do that, all right? Now we're going to graph the linear function represented by a table, okay? And so now when I have the table, I know what my x and my y are, and so I'm just going to graph each of these points. So my first point is negative 2, negative 2. Second point is 0, negative 1. And then my third point that I'm given in my table is 4, 1. Okay, now these aren't all of the points, these are just the ones that have been given. So let's go ahead and graph these, okay? So start at the origin, -2, go to the left, and then down -2, okay? So that's the first point. Then we got 0, we're not moving along the x, then we're moving down 1, and -1. And then we got 4, okay? Over 4 and then up 1, okay? So these points are kind of spread out, all right? What I can do is I can see, all right, from this point to this point, I can figure out what my slope is so that I could identify other points. So I could, you know, identify other points and, you know, add more points to this before I connect it, or I could just really connect it. But so first I'm just gonna draw some additional ones. So if I went up 1, then over 2, I know that my slope, okay, my slope for this, again, because I went up 1 over 2, my slope is 1/2, right? I'm going up 1 over 2, up 1 over 2. So there would be a point there, up 1 over 2, point there, up 1 over 2, another point there, up 1 over 2, another point there, right? Or I can go down 1, back 2. Okay, both of them are gonna be, again, I'm doing the opposite when I'm moving in the other direction. Instead of going up and over, I'm going back, down and back. Down 1, back 2, okay? And I could go on and on, but I have enough points, then I'm just gonna connect each of my points, drawing an arrow to say that that continues on, okay? The line continues, all right? All right, and then lastly, okay, graph the linear function represented in sort of this context situation. All right, so Mr. Redmond starts a long distance with a head start of 1 mile and runs the race at a consistent speed of 6 miles per hour. Okay, so he's starting at 1 mile. Okay, so on my graph, I'm gonna be starting at the 1 mile mark. So when I have at 0 time at the beginning, I'm at the 1 mile mark, and that is going to be our y-intercept. And then the speed is 6 miles per hour, okay? So for every hour that I go, and that is going to be our slope. That's the rate of change, okay? So my equation would be y equals 6x plus 1, okay? So that is my equation, all right? Now, again, I'm just going to graph it just like I did example number 1. I've graphed the y-intercept. Again, this is kind of like the starting spot. I start off at the 1 mile, and then I'm running 6 miles per hour. So I'm going to go, okay, up 6 and then over 1. Okay, so I'm going to go 1, 2, 3, 4, 5, 6, and then over 1. Okay, and I don't have much more room. Again, I'm running out of space here because my axes don't go all the way up to beyond 10. Okay, so really I could just connect these 2 points, right? Again, in a normal situation I would have a coordinate plane that has more numbers, but in this case I only have, and again this line's not great, but and there we go. Okay, so there it is. Okay, so when you have a context or a problem in a context, you just have to be able to write the equation. All right, and so we're going to get more practice with this as the unit goes on, but that's it. All right, so I want you to pause the video if you haven't already, and I want you to, again, use each example. I have another example similar, and you're going to do that one entirely on your own. Okay, and so please make sure you pause it. All right, I've done this. Use what I've done to see if you can do it on your own, and then check your answers here at the end here in just a minute. All right, so in example number 1 that you did on your own, we're going to start by graphing the y-intercept. Okay, so that is the y-intercept. That's at -4, so I'm going to go down, okay, -4, right, because that is 0, Negative 4 is the point, right? And then I'm gonna use my slope, okay? This is my slope, and I'm gonna use the slope to find other points. So I'm going up 2 over 3, up 2 over 3, okay? Up 2 over 3, okay? And I'm also gonna go down 2 and back 3, down 2 and back 3, down 2, down 2 and back 3, okay? And that's also gonna give me points, and then I'm gonna connect them. And that is our linear function for that one. For example number 2, I'm just gonna plot the points. I got negative 4, negative 2, then I got negative 3, 0, and I got negative 2, 2, 1, 4, and then 0, 6. Okay, and I'm just gonna graph those points. So negative 4, negative 2, then negative 3, 0, then negative 2, positive 2, then negative 1, sorry, that should have been negative 1, negative 1, 4, and then 0, 6, okay? And so if I'm looking at this, I see that my slope is up 2 over 1, okay? So my slope is up 2 over 1, so my slope is just 2, okay? I could find some other points, right? I could go down 2 and back 1, that also would give me some other points. And so I just connect this, connect the dots. I'm really struggling in connecting those, but you're gonna do a better job on your paper. So there you have it. Connect the dots, that is our line that forms our equation there. All right, and then same type of a problem. Ms. Johnson's running a race. She starts with 2 miles head start and then runs at a constant speed of 3 miles per hour. My equation is gonna be y equals 3x plus 2. Okay, that is her starting point. So the 2 is the y-intercept. That is what we're gonna graph. So it crosses the y-axis at 2, right? Put a dot there. And then I'm gonna use the 3 as my slope. Okay, so my slope is 3 over 1, or just 3. And so I'm gonna go up 3 over 1, up 3 over 1. Or then I'm gonna go down 3, back 1, down 3, back 1, okay? And then just connect my dots. Okay. And there you have it. All right. And so in this lesson, we have learned how to graph linear functions, giving a table, an equation, and a situation. Hope this helps. Hey, let me know if you have any questions. Like, comment, subscribe, do all the things, and good luck.